Hello, Alessandra. I'm going to discuss this problem with you, hopefully to the best of my ability. So first, I'll read the problem. Calculate the volume needed to produce a 0.8 molarity concentration of calcium hydroxide solution using, sorry, my phone just went off, using 37 grams of calcium hydroxide. Also, it tells you the MM in the capital letters, for those who don't know, means molar mass. So the molar mass means that the molar mass is 74 grams per mole. Okay, let's talk about this. I think you mentioned you mentioned inside of the questionnaire that you thought this problem was a stoichiometry problem. I think personally it's just a simple conversion problem. Also, seems like you're trying to solve for the wrong variable. I'm just trying to help you maybe clear up your train of thought. So anyway, basically, as you can see, I have an equation right here. In the purple, I have a giant M. That means molarity is equal to the blue N means moles divided by the red V is volume. And the question specifically asks always, when you're solving these type of questions, try to deconstruct the question, or take the question apart. It's saying calculate the volume right off. It should ask you for the volume. So it's asking for you to solve for the V. So that's why I have the question mark right there. So, but right off, with any algebraic equation, we got to find the two variables to solve for the other one. So we need to solve for the moles and the blue N and the purple M. So okay, so what is molarity? They gave it to us. In the problem, they said there was 0.8 molarity calcium hydroxide. All right, that was easy. The hardest part really is, what is the moles? What exactly is the moles in the problem? Okay, they actually gave it to you in a hidden way, because they gave you two things. They gave you a mass of calcium hydroxide, which was 37 grams, which is right here. Whoops, no, wait a minute. Right there. And also, they gave it to you in the molar mass, which is right there. So you could take 37 grams of calcium hydroxide. If you take this mass in these units with this substance, and you put it on the bottom of this fraction, it's called dimensional analysis. I learned this in undergraduate a long time ago. But anyway, if you put these on the bottom, specifically, if you take this and put it on the bottom here, these units, these cancel out, and it leaves you with these units, moles of calcium hydroxide, and you get the moles of calcium hydroxide, which is 0.5 moles. Okay, so we solved for the moles. That was the hardest part, really. What now? Okay, the next part is, do you know algebra? Okay, so basically, just from this equation we started with right here, you're going to do a little algebra, and you're going to swap the M and the V to rearrange into this new equation right here. V is equal to N divided by molarity, or moles divided by molarity. Okay, you take the moles they gave you, which is 0.5 moles, and you divide it by 0.8 molarity, and you get a volume. Specifically, I didn't mention right here the units of these. The units of these also are very important. Let's go for grain. This is always in the unit moles. This is in the unit specifically liters, or 1,000 milliliters. Same thing, no difference. 10 to the third milliliters, same thing. Also, the molarity is these units. Specifically, molarity is the units, moles over liters. But anyway, back to this. So that's why I had to explain where I'm getting this. Where am I getting that liters from? That's where I got that from. So anyway, if you divide these two, you'll get the liters of calcium hydroxide. Okay, guys, listen. I hope I explained that concept well. If you could, please patronize my tutorial page. I offer very fair prices, and I can tutor all types of chemistry. Check out my profile, and you'll find out what I'm talking about.